What do the clockwork orbits of planets have to do with the, let's face it, often chaotic world of economics? It sounds like a total stretch, I know, but stick with me because we're about to unpack a fascinating theory that connects these two worlds in a way you'd never expect. I mean, just think about it. On one side, you've got planetary orbits. They're elegant, they're predictable, and they're governed by these solid, unbreakable laws of physics. And then you have economic cycles, booms, busts, recessions. It all feels like it's driven by messy, unpredictable human psychology. They seem like they're from different universes. But what if they aren't? What if the very engine of our economy, the way capital flows and generates value, actually follows the same basic rules as a planet swinging around the sun? Now that is a bold idea, and it's exactly what we're going to dig into. To really get our heads around this, we first need to kind of shift our perspective on the economy. So instead of thinking about it as a straight line always moving forward, let's start picturing it as a cycle, a constant repeating rotation. Let's boil it down to the simplest economy imaginable. A chicken farm, right? The chickens are your capital, your resource. They produce eggs, that's your product. But then some of those eggs hatch into more chickens, which then lay more eggs. You see? It's a perfect repeating loop. It's a rotation. And, economists have been hinting at this all along, maybe without even realizing it. This right here is a classic model called the production possibility frontier. It just shows the trade-off a country has between making, say, guns or butter. But look at the graph. As a society shifts its focus from one to the other, the path it follows is an arc. It's part of a circle. The economy is literally rotating between its priorities. Okay, so if the economy is moving in a circle, what does that tell us about one of its most fundamental and, frankly, mysterious properties? Price. Well, this is where that connection to physics becomes incredibly powerful. So let's hop back to the 17th century. An astronomer named Johannes Kepler is just staring at mountains of data about the planets, and he has this huge breakthrough. He sees that planets speed up when they get close to the sun, and they slow down when they get farther away. But, and this is the key, he found one thing that never ever changed. The area they sweep out in a set amount of time is always constant. He discovered a conserved quantity. Physicists have a name for this special conserved quantity. It's called angular momentum. It's the same reason a figure skater spins faster when she pulls her arms in. Her mass and her speed change, but the total angular momentum of the system stays exactly the same, unless some outside force messes with it. So here's the big leap. If economic production really is a rotational system, then it too must have a conserved quantity. It has to. And this theory proposes that the economic version of angular momentum is price. Specifically, the price of a capital asset. All right, that is a massive claim. It sounds cool, but does it actually check out in the real world? Well, let's test it against two of the most important capital assets in all of history, land and stocks. For centuries, people couldn't really explain why land was valuable. I mean, you can't eat dirt. Then the economist David Ricardo comes along and just nails it. He said, look, land isn't valuable by itself. It's valuable because of what it can produce. The price of land, its rent, is high because the price of the corn it grows is high. The value of the resource is tied to the value of its product. Now, fast forward over 100 years. After the huge stock market crash of 1929, another economist, John Burr Williams, used the exact same logic for the stock market. Why is this piece of paper, a stock certificate, worth anything? Not because of the paper. It's because of the stream of dividends, the earnings it produces. A stock is valuable because its product is valuable. It's the same idea. And this is where the analogy just clicks into place perfectly. The value of an asset, its price or its economic momentum, is just the amount of the resource you have, whether it's acres of land or number of shares, multiplied by the price of what it produces, be it corn or dividends. The underlying math is identical. Okay, I see you. You're thinking, if price is a conserved quantity, why does it change all the time? What about stock market crashes and housing bubbles? Great question. For that to happen, you need to introduce an outside force. In any rotating system, when you want to change its momentum, you don't just push it. You apply something called torque. It's basically a twisting force. If you apply torque to a spinning wheel, you change its angular momentum. You make it spin faster or slower. So, what's the economic version of torque? It's the profit motive. It's that external incentive that acts as a turning force on the whole system. When a central bank, for example, suddenly jacks up interest rates, it's applying an economic torque. That changes the expected returns and profits, which forces the whole economic cycle to either speed up or slow down. So let's just step back for a second and appreciate what this framework gives us. By thinking about economics using the language of physics, of rotational dynamics, we end up with a new perspective that's surprisingly consistent and really, really powerful. So let's just run through the whole thing one more time. First, we see economic production not as a line, but as a rotation. Second, in that system, the price of a capital asset behaves just like angular momentum. It's the thing that wants to stay constant. Third, this gives us an incredibly useful formula. An asset's value is just its resource multiplied by its product's price. And finally, the force that changes everything is the profit motive, acting just like physical torque. What this model really does is move economics away from just trying to find patterns in past data and towards something based on fundamental laws. A lot like what Newton did for Kepler's discoveries about the planets. And that leaves us with one last huge question to chew on. If the core of our economy really does obey the laws of physics, what else about our financial world might be way more predictable than we ever dared to imagine?